Welcome back. Understanding what's happening under the hood of large language models, LLMs, will be key to navigating the digital world. In this module, I will provide more details on LLMs. I will also show you how these models might have learned from biased data. We don't know how much data was used to train large language models like ChatGPT. However, depending on their use, it might vary from hundreds of gigabytes to terabytes of data. Estimates for ChatGPT 3 are around 45 terabytes of uncompressed raw data. While the data used to train the model is smaller after processing and filtering, it remains an impressive large amount of information. Also, if the language model is used for general purposes, like ChatGPT, the data must be of high quality and diverse enough to learn different styles, topics, and structures. This allows me to point out the first two issues related to the training of large language models. The first relates to the ownership of content used in training large language models. In fact, there are ethical and legal complexities of using vast amounts of internet-sourced data, often without explicit consent from the original content creators. The second issue is the possible use of biased data. This is an important issue as large language models might learn, amplify, and perpetuate the societal biases present in their training datasets. Traditional machine learning models depend on clear-cut learning patterns like supervised, semi-supervised, or unsupervised learning. Foundation models, on the other hand, are primarily trained using a technique known as self-supervised learning. What makes self-supervised learning unique? Their uniqueness spawned from the fact self-supervised learning does not rely on pre-labeled examples. Instead, this innovative approach leverages the inherent structure of the data itself to automatically generate labels. This means it can learn from the data more naturally and efficiently without needing extensive manual labeling. Let's assume we are building a question-answering system. The model scans these texts to understand different contexts and informational segments. This stage is crucial for later defining questions and answers. Using a technique called sentence or phrase masking, the model generates a question based on the masked sentence. For instance, consider the sentence, "Neil Armstrong landed on the moon in 1969. The system can mask the term 1969 and generate the question, "When did Neil Armstrong land on the moon?" The masked part of the text, in this case 1969, serves as the answer to the automatically generated question. This technique leverages the context surrounding the masked word to formulate relevant questions that the model will later learn to answer. The model uses the pairs of automatically generated questions and their corresponding answers to train itself. It learns by trying to predict the correct answers to these questions based on the contextual clues provided in the text. Through continuous training, the model refines its ability to understand the context, improve its question comprehension, and enhance its accuracy in predicting answers. Another method involves generating multiple choice questions where one of the options is correct and others are plausible distractors. This helps the model improve its reasoning and deduction skills. The model is continually tested and retrained with new texts and new automatically generated QA pairs. This iterative process helps the model improve over time, making it more robust and reliable. This training approach allows the question-answering model to develop a deep understanding of language and context without needing a large data set of manually labeled question-answer pairs, making it a cost-effective and scalable solution for developing sophisticated AI-driven question-answering systems. You understand now how the self-supervised learning approach can create bias and amplify stereotypical issues. Consider the following prompt. Create an image of a typical Italian male from Rome. This is the image created. a well-dressed and stylish young man with monuments behind resembling the city of Rome with the Italian flag flapping on top. Okay, this is an acceptable image. Now, let's tune the prompt just a little. In this case, I have posed the exact question for an Italian male from Sicily. Somewhere, in the training data, there is this stereotypical relationship between Latin lover look and males in Sicily. This relationship was picked up during the creation process for this image. In this case, it might be a cute or even a humorous matter, but it does not take much to become offensive and generate harmful content. Next, I will look at how large language models work, and through these details, you will understand, for example, why such models make non-factual statements known as hallucinations.